Hey students, it is Mr. Rich. I hope that you all can hear me out there. I am a math coach here in Jacksonville, Florida, and I coach students for the ACT and the SAT, as well as doing a lot of high school math tutoring. And tonight what I want to do is do a 1-hour crash course on the ACT math section. I have tutored quite a few students for this test coming up this coming Saturday. And what I intend to do today is I'll share my screen with you now. Let's put my screen on here, and I will scoot over to right here. All right, so what I'm going to do tonight during our time together here is I am going to go over a pacing strategy for the enhanced ACT math section. As most of you know, that if you're taking the test this Saturday, it's what we call the enhanced version of the ACT. So it is it's had some changes to it. The math section, the major change is that it was shortened from a 60-minute test down to a 45-minute test. Questions went from 60 down to 45. So you've got 50 minutes, 45 questions, so a little bit more time per question, but still it works out to about 1 minute per question. So I'll talk a little bit about my recommended pacing strategy to get through the test in a timely fashion. The other thing that has changed on the enhanced version is that there are now 4 answer choices for every one of the multiple choice questions instead of 5 choices. I'll talk a little bit about the formulas, really just mostly to say, be sure to study the formulas and get a good formula sheet and look at that before the test on Saturday. I am going to talk a little bit about the concepts that are covered on the ACT test that are not on the that are not on the SAT test. Some of you I know have taken the SAT before and you're taking the ACT. There is a group of type of questions that you will see on the ACT that you have to prepare for that are not on the SAT. I will give you some last minute tips for this last day coming up tomorrow before the test, and then we'll get into the bulk of our session tonight is going to be to work some practice problems. Now, the ones that I'm going to be working on tonight, I would say we're probably a little bit more advanced type questions. So I'm trying to get the students, who are trying to get a bump in their score, obviously this Saturday, to be able to get some of those more difficult questions at the end, which I would consider questions right around the last 10, basically from question 36 to 45. So somewhere those problems I'm going to work tonight would be ones that you might see in that area of the test. All right, if you do have any questions about the ACT in particular, about the new enhanced version, you can leave a comment here, and I'll be sure to take a look at those comments as we go. You'll see when I move my head out of the way that I do have a TI-84. So I will, anytime that we need to use the calculator, I will pull up the TI-84. All right, so here we go. Let me talk just a brief couple minutes here about the pacing strategy. As I said, you've got 45 questions, 50 minutes. So what I am telling my students is that you really want to think about this test in terms of, let's suppose that you are a tester and your goal score is going to be, say, around 30 or higher. So you are maybe in the mid-20s and you're trying to get closer to a 30, right? If that is your goal, then what I recommend that you do is consider the test to be in 2 parts. I want you to consider it to be questions 1 through 35, and then questions 36 through 45. And so what you're trying to do is you're trying to get to that goal score of 30. You're going to spend a disproportionate amount of time on these first 35 questions here. And I would say you're probably going to be wanting to spend here right around, I would say right around of your 50 minutes, you want to spend about 40 to 42 minutes right there on those. And then when you get to these last 10 questions, I want you to be in the mindset of trying to get 5 out of the 10 on your first pass through the test. So you're going to make a really snap judgment each time you look at one of those questions, 36 through 45, and say, within about 5 seconds, is this the kind of question that I think that I could get right if I went ahead and spent another minute, minute and a half on this question? Or is it the kind, maybe you have a feel for that kind of question that you typically struggle with and you're going to skip by it? So you're looking for the 5 best questions for you out of those last 10. And if you do as well as you should on these first 35, and if you could get 5 out of 10 of those questions and maybe make guesses on the rest of them, educated guesses on a few, maybe pure guesses on some of them, and if you can get 6 out of those 10 questions, you're going to be doing great on this test. Now, if your goal score is going to be maybe a little bit lower than 30, suppose that you're maybe in the upper teens, low 20s, and you're just trying to get maybe to a 25 or a 26, maybe get into the mid 20s, then I would break it up into maybe questions 1 through 30 and then 31 through 45. And your gains are going to be made in those first 30 questions. You're not going to be making your significant gains by doing better on the 31 to 45 questions, right? So these are going to be the more challenging ones for you. So you want to spend a disproportionate amount of your time, again, maybe 40 to 42 minutes on those first 30, leaving yourself maybe 8 minutes to sort through those and find perhaps 7 or 8 of those that you feel comfortable answering. And if all you do is answer 7 or 8 and you don't even really spend any time on the balance of those, like on the rest of those, maybe 7 or 8 of the ones that you didn't answer, and you make pure guesses on those, that's going to be fine, because you want to be spending more time on these questions here. But I will tell you this, and hopefully as you've been practicing leading up to the test on Saturday, right, you do want to get your eyes on every one of the questions. You don't want to get to the end and say, well, I didn't get to questions 40 to 45. You want to be able to move through these last 10 or these last 15 questions at a very quick pace, skipping over the ones that look like they're harder for you, so that you get to pick the easiest of those last questions, the easiest ones for you. All right. So that is what I have to say about a pacing strategy on test day. And of course, when you're doing your practice tests leading up to test day, that's what you're practicing, right? You're practicing on getting through the entire test, time management. And hopefully you've been doing that up to this point. Now, the second thing that I wanted to mention tonight is about formulas. Now, I give my students a formula sheet, and these are some of the formulas that are on that formula sheet. If you've got a third-party book that you've been using, or if you've been using the ACT official book, there will be some formulas in there that you can study. And as you know, if you've taken the ACT before, you don't get a formula sheet. There could be some questions where they will give you formulas, but by and large, you need to know the formulas. Now, the ones that you probably want to be studying, I would say, would be making sure that you know your area formulas. And I think most of you probably know these, right? The area of a triangle, definitely, right? Area of a rectangle, square. Don't really need to worry too much about a trapezoid. I wouldn't worry about memorizing that. It might come in handy to know the area of a parallelogram, base times height, where one of the sides would be the base, but the perpendicular distance from that base to the opposite side, that's going to be the other dimension, the height that would be involved in the area. Let's see. You definitely want to be knowing SOHCAHTOA, right? You are going to see some geometry questions on the test this Saturday. So be sure that you know your ratios right here for sine, cosine, and tangent. And I'll mention this too, because I'm going to work some problems on these, but you do need to know the law of sines and the law of cosines. When they give you one of these problems, which is these problems are non-right triangles, what we call oblique triangles. So when you have a triangle that does not have a 90-degree angle in it, and you need to find an angle or a side, one of these two equations is going to be what you'll use. But it's kind of 50-50 whether they will give you those equations in the problem or not. So you have to be prepared that they may not give you the equations, so you need to know them. I will work a few problems here tonight using those two formulas. And that's one of the differences between the SAT and the ACT. I've never in my life seen them ask on the SAT a question on these oblique triangles. All right. Let's see. I think I've got another section here. No. Yeah, just some other formulas. To make sure you understand your slope formula, your midpoint formula, and your distance formula. It is a good idea to know the equation of a circle in the XY coordinate system. And there it is. So when you see a formula of a circle written like this, you know that the H and the K are the coordinates of the center. And then the square root of whatever that number would be on the right side of the equation there would be the radius of the circle. And notice that there is a minus, right, that's built into that formula, so that when you are looking at an equation and you're pulling the coordinates out, you do have to change their sign to get that center. And I am going to work some problems on circles because they are very similar to hyperbolas and ellipses, which is another difference between the ACT and the SAT. All right, so these were the things here that I mentioned earlier about concepts that you do need to cover on the ACT, but that you don't typically see them, or at least I've never seen them on the SAT. I mentioned the law of sines and cosines already. Ellipses and hyperbolas. I can say that I've never seen those asked on the SAT, but you do need to know those. These are typically not seen by students unless you take a pre-calculus class, maybe. Normally, you don't see ellipses and hyperbolas. They're not covered in the new AP pre-calc class unless you're studying Unit 4. Nobody studies that unit, or at least not before the AP exam. So a lot of students don't know much about ellipse and hyperbola equations. There are also, on the ACT, you can see what we call n factorial problems. I'll show you what I mean by that when we get there. And I'll tell you another thing too, logarithms. You're going to see possibly a question, and sometimes in the past they've had 2 questions on logarithms. An easy one maybe towards the front and a harder one towards the end. And also matrices, which is another topic, at least in my state in Florida, that a lot of students don't get exposed to in through their Algebra 2 class. And I think they started teaching it in Algebra 2 in the last couple of years, but I'm going to work a few matrices problems for you tonight. All right, so those are the concepts there. Now, what I was going to recommend for you, just some general tips here, since you only have about 36 hours before the test. And these are all just suggestions. If you have time, right? Do another practice test is what I would recommend that you do. Hopefully, you've got the new enhanced practice tests that are in the ACT Red Book. If you don't have those, then use the enhanced ones, right? You just want to get a lot of reps in, as many reps as you can working practice problems. So if you can do that Friday, definitely don't want to do it late at night, but if you have time, do that. The other thing that you can do the last day is maybe take a look at your past practice tests and some of the problems that you've worked during your prep in the last few weeks. You want to be looking at the problems that you've missed and remind yourself, what was it about that problem that caused you to miss it? Was it a formula you didn't know? Is it a concept that you need to refresh yourself on? So definitely that is one area you can focus on with just a limited time left before the test on Saturday. Probably a good idea too, maybe the morning of the test, review the formula sheet and look at some of the key formulas to remind yourself what those are. And the last tip that I have for you really is get everything ready to go Friday night, because you're going to have to get up early Saturday and definitely eat a breakfast and but get your clothes laid out. Be sure that you layer your clothes, because you don't know what the testing site's going to be. It could be warm, it could be frigid. You never know. So take a jacket with you so that you're not uncomfortable. Try to be as comfortable as possible throughout the test. Okay. And I saw a good tip from somebody the other day about doing your practice tests with a YouTube channel on that mimics test room noises. So if you go into YouTube and you Google or YouTube search test site noise, you can find somewhere you start the video and then all it plays is noises like someone coughing or papers rustling. So sounds that you would hear during a test, just to get used to taking a test in those conditions. All right. And again, if you're here watching and you have any questions in particular about getting ready for the ACT here in these last day, let me know. Post that over in the comments, and I will keep my eye out over there for that. Well, now what I want to do is I want to work some practice problems for you. And so I'm going to start with this. This is going to be a law of sines, law of cosines problem. And so here is the problem. So it says the sides of a scalene triangle measure 12, 15, and 17. To find the measure of the smallest angle of the triangle, which of the following equations can be used? Well, what we're going to do is we're going to go ahead on our scratch paper and draw a picture of this triangle, right? So you want to do that on geometry problems that don't give you a picture. And so we'll just label these sides 12, 15, and 17. Now, the smallest angle has to be the angle that's opposite the smallest side. So this has to be the angle, and we will call that angle theta. That's what they're calling it here in this problem. So that'll be theta. Now, you can tell from this that they are using what we call the law of cosines. And here's what the law of cosines looks like. And it was on the formula sheet that I showed you, but I'm going to write it. It starts off looking like the Pythagorean theorem. C squared is a squared plus b squared. However, there's a third term that's tacked on to the end of it. And it would be the number 2 times the product of those two sides, AB, and that multiplied by the cosine of the angle that's opposite that side, C. We call that big C. So these are the three sides right here. And that is one of the angles, the angle that's opposite that. So at any rate, what they're wanting us to do is to find this angle. So that means then that these would be the two sides that would go in right here. This 12 would have to go in right here, because this would be our angle theta. So whatever that angle is right there, this side has to be the one that's on the opposite side from that angle, which would be 12. So you can see that we would be looking at A and D because they have the 12 squared and the 12 squared. And then look at the end right here. The only difference between these two is cosine and sine. And this is just a total misuse of the equation. There's never going to be a sine right there. So that is going to be a no. And our answer is going to be A right there. So when you look at this problem, you can see there what we are doing is we were saying that this is angle C according to our formula. We called it theta, but it's angle C. This would be side C, little c, and then that would be side A and B right there. Okay, and that's it. So by the way, as soon as I saw this question, if I saw a law of cosines formula with sine right here, I know that I'm immediately rejecting those answers before I even do anything, because I can't have a sine of an angle at the end of that equation. Let's do, I think I've got another one here. So yeah, this will end up being a law of sines problem. So let's take a look at this one. This says in triangle FGH shown below, a side length is given in inches and angle measures are as marked. Which of the following is an expression for the length in inches of side length FH? So this is the thing that we are looking for here, that side length. Now, in this problem, they did give us the law of sines equation right here. All right. Now, the way that this equation works for the law of sines is that if you know in your picture, in your triangle, if you know an angle and one of the, and you know the side length opposite that angle, that means you know one of these ratios right here. Because this says that if you have an angle in your triangle and you know the length of the side opposite that angle, that ratio, the sine of the angle over the angle or the side length opposite, that ratio is the same for the other angle side pairs. So what I'm going to do here to solve this problem, if I'm looking for this side, I need to make a ratio of sine of 43 degrees divided by the length of the side opposite that angle, which would be 40, and then set that equal to a side or an angle that I'm looking for. Now, I am looking for this side x, so that's going to be the unknown right there. But then that means I need to know angle G, because I would be putting here the sine of that angle that's opposite the side that I'm going to use in my ratio there. Well, I can figure out what that is. I will move myself up here, revealing our TI-84, and I'll just take 180 and take away those other two angles, right? 43 minus 22, which is 115. So we know that this angle is 115. All right, and so that's the formula that I would use to find that missing side length. If I cross multiply, I get x times the sine of 43 is equal to 40 times the sine of 115, and then I would be dividing by sine 43. And that gives me the x that I'm looking for. And then when you look at your answer choices, we can match that up. And it looks like answer E. So you can tell this is one of the old style questions because it's got 5 answer choices. But the new one, as I said, has only 4 answer choices. So there it is. So that's going to be my my answer there. Now, I want to show you one other thing about law of sines and law of cosines. Going back to this problem here, one of the most typical configurations of the triangles when you are doing the law of cosines is that you know two sides and you know, or trying to find the angle that's sandwiched between them. In other words, this is what we call a side angle side configuration. I know two sides and then the angle in between them is known, or I'm trying to find that angle. And if that's the case, side angle side here, then you'd be using the law of cosines and not the law of sines. So that's just kind of a general rule there. All right, so be sure to review those formulas on a formula sheet: law of sines, law of cosines. Well, the next thing that oh, and by the way, I'll make another comment about this. You know, when I was talking to you about the pacing strategy, the questions on the test go from easy to hard. If you've taken one of these ACTs, you know that generally speaking, you've got easy questions 1 through 10, but then when you get to the end, 36 through 45, those are typically going to be harder questions. So normally these problems here, the law of sines, law of cosines problems, we typically see those towards the back end of the test, maybe somewhere between question 31 through 45. So they do consider these to be the more challenging problems, but I think they're doable problems for you if you know those formulas, because as I said, you may not be given the formula on the test, but if you know the formula and you've done some practice problems with these, those are definitely doable as one of those problems towards the end of the test. All right. Now, this right here is an ellipse. Now, here is what I do to quickly train students on how to handle these problems. If you see an ellipse or something that's closely associated with it, is this, which is called a hyperbola. As I said, you probably haven't seen those before, but I know something that you have seen, and that is the equation of a circle. So I'm going to rewrite here what I showed you earlier as the equation of a circle in the XY coordinate system. All right, that's what it looks like there. Now what this tells us is there's a center there, but at h comma k, and there's my radius. But what I wanted to show you is that if I did give you the equation of a circle, and so let's suppose it looked like this. That would tell you that the center of this circle would be at 4, comma, -5, right? You change the sign on these. So your center, 4, comma, -5, and you would know that your radius is going to be the square root of 36, which is 6. Now, one of the ways you could write the equation is you could, if you wanted to, we don't normally do this. I'm just pointing out that what I could do is I could divide both sides of this circle equation by 36, giving you a 1 on the right-hand side. Now, what does this tell me? This tells me that if you took the square root of those two numbers, the 36 and the 36, which is obviously 6, this gives you the horizontal distance from the center out to the edge of the circle, which is called the radius, right? And so you go out 6 units, 6 units. Now, why am I showing you this? Because an ellipse is a circle that essentially has been stretched in one direction. So it's no longer a perfect circle. It's now looks like an oval, or what we call an ellipse. You can tell that this is a circle that was stretched longer horizontally. Well, here's the center. The center for the ellipse is at 0, 0. So that means the h and the k in its equation would be 0. And this is just a modified equation to the circle. What it is this. That distance from the center of the ellipse is 8. So therefore, 8 squared is 64. So there has to be a 64 underneath the x squared. What's the vertical distance from the center to the edge of the ellipse? Well, from our picture here, it's 5. So that means there has to be a 25 underneath there. And so I know by looking at this ellipse and just modifying this equation of a circle, by knowing that this is kind of like a horizontal radius. We don't really call it that, but let's call it that for our purposes. It's a horizontal radius of 8. So I got to have a 64 underneath there. So this is going to be the equation that goes with that ellipse. All right. So that's what you have. So notice an ellipse, its equation is just like a circle. The only difference is you've got these two different numbers underneath here that represent their square root, represent the horizontal and vertical distance from the center to the edge of the ellipse. Now, the hyperbola doesn't look anything like a circle or an ellipse, but its equation is set up in just the same way. This really isn't like an ellipse that's been exploded to move outward. What is the difference between this equation for this shape and the ellipse and the circle? There must be a minus sign between the two fractions. So right away, I know that h and j for this are not going to be my answer, because when it's a hyperbola and which looks like this, then I know it's got to have a minus in between. Now, the center of a hyperbola is going to be the halfway point between those 2 points that we call the vertices. And you can tell that this point right here, this is x equals 1. This is x equals 3. So this is x equals 2, halfway between those, with a y of 2. So the center is 2, 2, which means I need to have x minus 2 and y minus 2. And I got rid of these two because they had a plus, not a minus. I can get rid of this one because it's got the wrong center. That's supposed to be x minus 2 and y minus 2. And so F is going to be my answer right there. All right. Now, notice the distance, the horizontal distance from the center out to the edge is 1. From 2 to 3 is 1. That's why there's 1 squared underneath the x, because that's the horizontal distance from the center out to the edge. So that is what the hyperbola looks like. So just kind of to recap that, I don't think I have another hyperbola ellipse question, but I just want to show you again what our equations are. So here's our circle equation. equals r squared. When it comes to an ellipse, it's going to be x minus h squared plus y minus k squared. But there will be a 1 over here. And what you have here is you have an a squared and a b squared, two different numbers. And the square root of this number will give you the horizontal distance from the center out to the edge of the ellipse. The only difference then between the equation of the ellipse and the hyperbola is the fact that there's going to be a minus right here. Now, it could be either this is the positive fraction and the y is the negative fraction. That just determines which way it's oriented, but we don't need to get into that. I just need you to know the difference between those, and you have a decent shot at getting the equations correct on a hyperbola or ellipse. All right, students, if you've got any questions, let me know. I am looking over at the comments. I don't see any comments coming in, but feel free to post something over there. Before we move on, I did just want to mention one thing to you, and want to show you this right here. So this, I do quite a bit of tutoring, and I have a team of tutors that covers all of the math classes, also physics and chemistry. So if you do have need for tutoring, you can see my email address down there at the bottom. Feel free to reach out to me and we can get you connected with a tutor. And as I mentioned, I do ACT and SAT prep tutoring quite a bit. And I do have groups that start. So I do group tutoring as well. And my first ACT group tutoring is going to be starting next January for the February ACT. That's going to be a big one in our county because a lot of students are going to be taking that test. So if you have any need for tutoring services, let me know. I'd be happy to help. I also do an AP Pre-Calc group. So in our area, AP Pre-Calc is a huge class. It's an important class that students are taking to get ready for their calculus class. And I have an AP Pre-Calc group that meets on Sunday nights at 9 o'clock. And we spend an hour Sunday night doing homework problems, test prep, answering questions. And then also as a part of that group, then you get entrance into my classroom that has extra resources and videos and practice problems too. So, and that's a $100 a month subscription. So if you're interested, let me know and I can connect you with that class. All right, so let's go back to work a few problems. I wanted to talk about logarithms, right? So logarithms is another one that you could expect to see. Sometimes there are easier log problems that they will put more towards the front of the test, maybe somewhere around question 20 or so. But there are times when they put a more challenging one towards the end in those last 10 questions. And I know that if you've been through Algebra 2, you've seen logarithms before, although I do realize that logarithms are tricky for a lot of students. They do trip students up and they kind of are afraid of them because they don't quite maybe understand them. So let's look at some problems. I'll show you the key things you need to know about logarithms to get these right. So here you've got, on this problem, the log base a of 5 is equal to -1. What is the value of a? Well, what you want to do when you're faced with a logarithm, usually on the ACT, if you can convert the equation from its logarithm form into its exponential form, that's going to allow you to solve the problem. Now, the question is, how do you get it from log to exponential? Well, there's two ways of thinking about it. One of the ways that your teacher may have taught you this in Algebra 2 is you take the base of your logarithm, in this case it's base a, and you move that to the other side of the equation, and then the other side of the equation shrinks and becomes the exponent to the base of an exponential. And when you make that move over to the right side, you leave the argument of the logarithm, the 5 in this case, right there. And so this equation really, when you convert it from log to exponential, is 5 equals a to the first power. And if you're solving that for a, If you raise to the minus 1 power on both sides, that becomes a to the first power, and this becomes 1/5. And a is 1/5. That's going to be our answer. Now, let me show you what you can do on the TI-84 as another option here. There is a logarithm function that's hidden in the math menu of your TI-84. So if you click on the math button and you scroll up to get to the bottom of this list, you'll see log base. So one of the things that you could do is you could say, well, how about if I pull up log base? I'll put a 5 in here for the argument of the log, and let me try all the different answer choices to see which one of those gives me the answer. So here I put in the answer A as the base of that logarithm right there and hit enter. Well, it doesn't like that. So let's go back and see. Then we would assume that either we made an entry error or maybe you can't take that. So maybe that's just not an acceptable answer. So let's go back over here and get rid of that minus and try answer B, 1/5. So log base 1/5 of 5 gives me the correct answer of that I was looking for, -1. So this is what we call back solving, right? I'm using the answer choices in my equation to see which one makes the equation true. And so there you go. So you really could do this without knowing anything about logarithms. All right. Now, your teacher may have also told you the way that you get rid of this logarithm is you do something like what we call exponentiate. If you raise a power on both sides, that cancels those. It leaves you 5 equals a to the minus 1. And a to the minus 1 is 1 over a. And then you flip both sides, you get 1/5 is equal to a. And there's your answer. So that is a logarithm. Yeah, Stephen, I'm definitely going to go over those n factorial problems. Yeah, those are most students have not seen those problems in their algebra class. So yeah, I've got one of those. Thank you for asking. So I'm definitely going to cover that. And let's go to another log. This would probably be maybe a log question that would be more of the difficult type in the latter part of the test. This says, what is the value of x in this equation? Well, again, you could use log base on this, right? You could actually put this into your calculator as an expression and get a number, and then try each of these answer choices for x and see which one of these would match that answer. But let me show you what they want you to know here. What you learned about logarithms in Algebra 2 is that you can condense subtraction between logs, and you can condense those by division. In other words, this can be rewritten over here on the right-hand side as log base 3 of 18 divided by 2, which is 9, like that. And then what we want you to know is that the log base 3 of 9 is actually the number 2. If you didn't know that, one of the ways that you could know that is we like to rewrite those arguments. That 9, we want to rewrite that so that its exponential base matches that base, and those cancel out, and it gives me an answer of 2. But again, if you got yourself to that point, or even if you didn't know what you could, that you're supposed to condense that, you could use that log base. You could come up here and say, okay, fine, log base 3 of 18 minus, and then call up the log base again. And we'll do log base 3, once again, of 2. Hit enter, we get an answer of 2. So now the equation is log base 7 of x is equal to 2. And remember on the last problem, I told you that if you could convert from log to exponential, it's probably going to solve your problem for you. That's certainly the case here, because if I take this 7 to the other side, it becomes from a base of a log, it becomes the base of an exponential. That 2 becomes the exponent. It leaves the x there. There's my answer, 49 right there. All right, so logarithms. Don't fear logarithms. Those are, if you can understand those steps I just showed you there, and maybe with this log-based function, you might be able to knock out a logarithm problem on this test. Okay, I wanted to show you this one. This is a trigonometry problem. This one, I believe, comes from, I just worked this with a student today. This one comes from one of the practice tests on the ACT, and it involves obviously here a right triangle and a circle. Now, everything that they're giving you in the paragraph is marked here. So the question is, which of the following values is closest in centimeters to BP? They want me to find that distance. Well, to find that distance, what we're going to have to do is definitely find the length of all three sides of this triangle. Now, notice that when it involves a right triangle, your logic or your thought process should be this. One thing that I could use in right triangles is a squared plus b squared is equal to c squared. However, in this particular triangle, we can't use that because I only know one side. This only helps me find a side when I know two of the three sides. However, it's pretty apparent they want me to use trigonometry here because they've given me some trig functions down here. So what I'm going to do is find one of the other sides. I'm going to try to find the side over here, AO, to start with. So I will then say, okay, the angle that I know, 20, that side is the opposite side. That side is the adjacent side. That means that I would be using the tangent function because in SOHCAHTOA, TOA, right, TOA, tangent is opposite over adjacent. So what you do when you're using one of these trig functions is you write the formula down, right? The tangent of an angle, in this case 20 degrees, is equal to the ratio of the opposite side, which is AO, the length of AO, divided by 12. So AO is going to be equal to 12 times tangent of 20 degrees. And let's go to our TI-84 calculator here. So we will do 12 times, and I'm going to use their numbers over here, 0.364. So 4.368. So I know that this side over here, AO, is now 4.368. Now what I'm going to do is I'm going to use the Pythagorean theorem and go ahead and get the third side. I'm assuming if I'm going to get BP, I'm going to have to find that whole side of that right triangle. So I'll just use the Pythagorean theorem. So I'm going to take 4.368 and square it, because that's one of the legs that we just found, right? Plus 12 squared, which is 144, equals, but I need to square root that. So I will hit the square root button, arrow up to grab that answer. It blows into the square root, enter. So now I know that the hypotenuse from O to P is a length of 12.77. And then I'm like, well, that's not what they want, right? They don't want me to get the whole thing. They only want me to get this part right here. And then I realize, wait a minute, this distance from O to B is the same as A to O because they're both radii of the circle. So if that's 4.368, so is that part. And now it's just a matter of subtracting those to get the desired segment BP. And when you subtract those, we're going to get 8.4. And that's going to be our answer. Next. Now, this is what Stephen was just asking about, the n factorial questions. So let me show you this. Now, they at least in this question, ACT gives you the definition of what factorial means, right? But for most students, if they haven't seen a problem like this, their explanation while you're taking the test is probably not going to help much. But they do tell you that 4 factorial is by definition 1 times 2 times 3 times 4. Or stated another way, when you look at this thing, they want me to match this to one of these. Well, 6 factorial means take the number 6 and multiply it by all the numbers, all the integers back to the number 1. So I've got that in the numerator. Down here, I have a 3 factorial. So that would be 3 times 2 times 1. But now the question is, what in the world is n plus 1 factorial? And n is an integer. So what it means is this. Factorial means you start with the number that's being factorialized, if that's a word that has the factorial. So it's n plus 1 would be the first number. Well, with factorial, what do you multiply that by? You multiply it by the next integer that's 1 less than that one. Like the 6 I started with, I multiplied it. The next one was going to be 1 less than 6, 5. Well, what's 1 less than n plus 1? It would be n plus 1 minus 1, which is n. So the next one would be an n. But what's 1 less than this to get the next integer? It would be n minus 1. And the next one would be n minus 2, and so on and so on. Now, down here, you have n. So you would start with n, and then you would multiply that by 1 less than n minus 1. And then 1 less than that would be n minus 2, and on and on and on. Well, what happens in these problems is that you see that this one here, from n all the way back, is going to get canceled out or divided out by all of those. So those are all gone. And the only thing that you've really got left to calculate as a part of your answer is the n plus 1. Here, the 3, 2, 1 and 3, 2, 1 are going to cancel out between top and bottom. So you're just left with an n plus 1 and 6 times 5 times 4, which is 120. 120, n plus 1. There's our answer right there. So if you can follow that, then you are going to be good to go on the n factorial type of problems. All right, I think I've got enough. Yeah, so I wanted to cover matrices, a few things on matrices. Yeah, I've got a few matrix problems. Now, the way that I explained it to students that some of the easier matrix problems that they might put early in the test, your algebra instincts would probably allow you to get them. For example, if you had never seen a matrix or even heard the word matrix or matrices before, I think you could figure this problem out. This says that there are 2 by 2 matrices A and B, and they are related to matrix C by this equation. What is matrix C? Well, you know that that means 2 times A. So if I told you to multiply that group of numbers by 2, you'd probably say, I think I probably multiplied everything by 2, kind of like a distributive property, and you'd be right. So 2A, the matrix 2A would be 6, 10, negative 4, and 2. And then 3B would be multiplying all the matrix elements by the number 3. So that'd give me a negative 12, 15, a 6, and a 3. And then we're supposed to subtract those, right? I got a 2A and a 3B, and now I'm going to subtract. And if I told you to take this thing minus this thing, hopefully you would say, you know what? Probably the best bet would be to subtract their corresponding elements. In other words, the answer to this is probably going to be 6 minus negative 12, which is an 18, and 10 minus 15, negative 5. And if you did that, you would be correct. That's exactly what you're supposed to do. And you can see very quickly that your answer here is F. So that's how I would call that a simple matrix problem. A few other things I want you to know about matrices for this test. Now, I'm going to come back and do that one after I do this one. No, I think I have another one. Yeah, I want to do this one. There is something that you need to know about what we call a 2 by 2 matrix. What I'm going to tell you here is that you have to assume on this problem that they would not give you the first sentence. See, what they do in this problem is they're giving you the definition of what's called the determinant of a 2 by 2 matrix. See, this matrix is 2 by 2 because it has 2 rows. Those are the rows. and it also has 2 columns. So it's 2 by 2. Now, what they may ask you on this test Saturday is what is the determinant of the matrix? And if they don't give you the definition, you're out of luck. You have no idea what it is. Well, they tell you what it is here, but I'm just going to show you what it is. It is, if you're given a 2 by 2 matrix, it means you multiply the first diagonal, upper left to lower right, A times D, minus whatever the other diagonal product is, BC. And you see, they give us that formula right there. But sometimes they'll give it to you, sometimes they don't. Now, I just wish they would make a firm and fast rule. They're either going to give me the formulas on these problems or they're not, like on the law of sines and cosines. Why not just tell us, hey, we'll give you the formulas, or we're not going to give you the formulas? So since it's either way, you got to be prepared and know the formulas. So that is what we call the determinant of a matrix. Now, in this problem, though, it's not just a matter of like calculating the matrix or the determinant. They make another kind of question out of it. They say, if the determinant of this matrix is equal to -9, what would y be? So you have to make an equation out of this. You have to say, well, the determinant would be y times y, which is y squared, minus the other diagonal product, which would be 6y. And they told me that that answer is supposed to be -9. So that is a quadratic equation that you would solve. We will solve this like we do any other quadratic, and we're going to do that by factoring, by bringing that -9 over. And then we can see that this is going to be y minus 3 times y minus 3 equals 0. So my answer is y equals 3. And yes, that's what they were asking me for. So E is going to be my answer for that problem. Now, if they gave you a determinant or a 2 by 2 matrix that was pure numbers, yeah, that would be very easy. If I gave you 7, -2, 3, and 1. Well, what would be the determinant of that matrix? Well, the determinant of this matrix, if I take the determinant of the matrix, it would be 7 times 1 minus 3 times -2. The determinant is the number 13. There are determinants for other matrices, like a 3 by 3 or 4 by 4, but those aren't on the test. And it's a good thing because, yeah, it's much more difficult than a 2 by 2. So that's how you do a 2 by 2 matrix. All right, students, back up here. I did want to talk to you about matrix multiplication. What do you need to know about multiplying matrices? Well, I tell my students, if you had to figure out on the fly how to do matrix multiplication, you would never guess right. It would make no sense. There's no way for you to know how to do matrix multiplication. So I'm just going to give you this quick tip. If you are multiplying 2 matrices together, let's just call it matrix A times matrix B. You can't multiply all matrices. It all depends on whether their dimensions are, if their dimensions are accommodating each other. How do you know if you can multiply 2 matrices? Well, what you have to know is this, that if you take the number of rows of the first one, so if A is a R1 by C1, it has R1 rows and C1 columns, and B is, it's got rows R2 and C2. The only way that you could multiply the 2 matrices together is if the columns right here of the first matrix is the same as the rows of the second matrix that you're multiplying it by. If those two do not match, you can't do the multiplication. It doesn't exist, or it's undefined. Now, what if these do match and you have the same columns and numbers of rows there in the dimensions? Well, then the answer would have the dimensions of R1 by C2. Like that. Let me give you an example. If I have a matrix which is 4 by 2, and I multiply it by a 2 by 3, I can do the multiplication because I have a match right there between the 2 and the 2. And the resulting matrix, after I got done doing the multiplication, it would be a 4x3 matrix. Okay, that doesn't tell you how to do the multiplication. It just tells you whether you can or can't do it. In this problem, it's asking us, if A is a 2x2 matrix and the product is a 2x3, which could be matrix B. So if you're taking a 2x2, which is what matrix A is, and you're multiplying it by a matrix, and you're getting a 2x3 as a result, then we know that this has to be a 2x3, because you have to match those two, and you need a 2 and a 3 on the outside dimensions, 2x3. So which of these matrices is a 2-row by 3 column? There's only one. It's this one. You've got 2 rows by 3 columns. All right, students, that takes us right up to 8 o'clock, and we covered the things that I wanted to cover tonight for you. I hope it was helpful. I wish you all the best of luck on your test on Saturday, and if there's anything I can ever do to help you, don't hesitate to reach out to me. And again, I will put up my contact information up here so you can take a look at it. At the bottom is my phone number and my email address. If I can be of any help to you. I'll also tell you this one last thing. I do a free live stream every Sunday night at 8 p.m. on this same YouTube channel where I answer students' questions on math homework. So I do that. If I don't get questions, I've started doing SAT and ACT questions. So if you ever just want to get some extra math help or maybe look at some ACT, SAT prep, come see me here at this channel Sunday night, 8 o'clock. All right, everybody, that's going to be a wrap up for tonight. Good luck on Saturday, and thanks for stopping by. Bye, everybody.